In most interviews, one of the commonly asked questions is about the Fibonacci series. So, in this video, we are going to talk about the Fibonacci algorithm, how it works, and how you can implement it easily. Hey, I am Vijay. Welcome to VL Coding channel. So, what is Fibonacci numbers? The Fibonacci numbers are very useful for introducing an algorithm. So, before we continue, here is a short introduction to Fibonacci numbers. The Fibonacci numbers are named after a 13th century Italian mathematician known as Fibonacci. The two first Fibonacci numbers are 0 and 1, and the next Fibonacci numbers is always the sum of the two previous numbers. Like here is the 0 and 1 or the two constant numbers, and if you want the next number, we have to add the previous two numbers. Here 0 and 1, the sum is 1, and if you want the next number, and same process, like 1 plus 1 it's 2, and next thing is 1 plus 2 it's 3, and next 2 plus 3 it's 5, and 3 plus 5 it's 8, and 5 plus 8 it's 13. Like that we generate the Fibonacci numbers. So to generate a Fibonacci number, all we need to do is to add the two previous Fibonacci numbers. The Fibonacci numbers is a good way of demonstrating what an algorithm is. We know the principle of how to find the next number. So we can write an algorithm to create an Fibonacci numbers as possible. To show the difference between loops and recursion, we will implement solutions to find Fibonacci numbers in three different ways. One is an implementation of the Fibonacci algorithm above using a for loop, and second one is an implementation of the Fibonacci algorithm above using a recursion, and the third thing is finding the nth Fibonacci number using a recursion. First method is implementation using a for loop. It can be a good idea to list what the code must contain or do before programming it. Two variables to hold the previous two Fibonacci numbers. A for loop that runs n number of times, and create a new Fibonacci number by adding the two Fibonacci previous ones. Print the new Fibonacci number. Update the variables that hold the previous Fibonacci numbers, that the two Fibonacci numbers. So let's move into the coding part. First we have to assign constant Fibonacci numbers, that is 0 and 1. Let's first Fibonacci number, that is previous to value is 0. This is the first Fibonacci number, and second Fibonacci number is 1. Let's print these two Fibonacci numbers, as previous to and pre 1. These are the first two Fibonacci numbers, and here we using for loop to generate the remaining Fibonacci numbers for I in range of 18. So here we are going to generate 18 Fibonacci numbers. First we have to assign a new Fibonacci number, this variable. In this variable we have to store the sum of two previous numbers, that is previous number 1 plus previous number 2. Here comes the new Fibonacci number, and we can print this Fibonacci number, that is new Fib, and also we want to update the previous numbers also. So previous number 1 equals to new Fibonacci, I mean it's the current Fibonacci number, and pre 2 equals to pre 1, like that. So when we run it, here if you see, these are the 18 Fibonacci numbers. So we generate 18 Fibonacci numbers using for loop. So the next thing is implementation using recursion. Recursion is when a function call itself. To implement the Fibonacci algorithm, we need most of the same thing as in the code example in previous slide, but we need to replace the for loop with recursion. To replace the for loop with recursion, we need to encapsulate much of the code in a function, and we need the function to call itself to create a new Fibonacci number as long as the produced number of Fibonacci numbers. So in previous video we saw generating Fibonacci numbers using loop. So in this video we generate Fibonacci numbers using recursion. First we want to create a function Fibonacci of n, means it accepts the n value. If n value is less than equals to 1, return n. Why? Because we already know that 0 and 1, these are the values. One is index value is 0 and another one is index value 1. So if it's less than or equals to 1, it returns that number only. There are two Fibonacci numbers are constant. Else return Fibonacci of n minus 1. This is the second Fibonacci number, plus Fibonacci of n minus 2. We already know that the sum of the two previous Fibonacci numbers is the current Fibonacci number, like that. So we want to now we generate 10 Fibonacci numbers. So for I in range of 10, so here we are going to generate 10 Fibonacci numbers. Now we are going to call that function by Fibonacci of I and n equals to this. So here it loops from 0 until 9. So it first returns the 0 value and it calls the Fibonacci function and it returns whatever the result that it generated in this function. So let's see the result. Here if you see, these are the 10 Fibonacci numbers: 0, 1, 1, 2, 3, 5, 8, 13, 21 and 34. So the last one, finding the nth Fibonacci number using a recursion. To find the nth Fibonacci number, we can write code based on the mathematical formula for Fibonacci number n. It is f of n equals to f of n minus 1 plus f of n minus 2. Here you can see the n minus 1 is the previous one, the next before the number, and f of n minus 2 is next to the before number. This just means that, for example, the 10th Fibonacci number is the sum of the nth and 8th Fibonacci number. The formula uses a zero based index. This means that to generate the 20th Fibonacci number, we must write f of 19. When using this concept with recursion, you can let the function call itself as long as n is less than or equals to 1. If n less than or equals to 1, it means that the code execution has reached one of the first two Fibonacci numbers, 1 or 0. The code looks like this. So the third one is finding the nth Fibonacci number. This is the question in many of the interviewers asked. So first we define a function Fibonacci of n. It accepts the n value, and if n less than equals to 1, return n, else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. So suppose if you want to print 7th Fibonacci number, like n equals to 7 print of f the nth Fibonacci number is Fibonacci of n. Let's print the result. Here, yeah, let's print. Here the nth Fibonacci number is 13. Let's clear the terminal and run again. Here we see the 7th Fibonacci number is 13. Suppose if 6th Fibonacci number is 8. That's it. Here is a quick question for you all. Read the question and comment on the answer below. If you found this video helpful, don't forget to like, share and subscribe for more coding content. In the next video, we'll dive into arrays, their structures, operations and why they are important in programming. See you there.